Okay, this is the review for quiz 2.3, 2.4 on graphing linear functions and on writing linear equations. So the first 11 problems are all for graphing linear functions. So in the case of numbers 1 and 2, you're given a slope and you're given a point. So really, it doesn't take much work to graph these. But the first one tells you that the slope is -2, and at the point you go through is 2, -3. So in this case, what you want to do first is plot the point to -3, over 2, and down 3. Okay. Also, you want your slope to always be a fraction when graphing, so you need to make that a -2/1. Okay, so from the slope then, from the point that we started with, -2/1 means down 2 and right 1. When you think about rise over run, down 2 and right 1. And then your line would go between those 2 points, like that. Number 2 is the same idea. It gives you a slope that's already a fraction, 3/4. And it tells you it passes through -4 from the 3, which means that the first thing you do is plot the point -4 and then go up 3. So from there, we actually need to, according to the slope, rise is up 3 more. So from here, up 3 and right 4. Back over here again. And once we have that, we can connect it and be done. It's probably the simplest thing you can do is to have a point and a slope just given to you. It's pretty easy to graph. Even numbers 3, 4, and 5 are really the same idea. You have a starting point, except and you have a slope, except that in this case, it's in the form of an equation. So this time you have to graph this equation, which you should know is called slope-intercept form of an equation. So in this case, you're given a y-intercept right here at -4, and then you have a slope 1/2. So in this case, a y-intercept means the point where the graph touches the y-axis. So we need to go to where the graph would touch the y-axis at -4, right there. So since we have that point, now we're going to use the slope to find the other one. Up 1 and right 2. Right there. And you are done with that. The same thing is true for number 4. It's another equation of the same sort. -4x plus 2. Right away, I would say when I go to graph this, I'm going to put my -4/1 so that my slope is a fraction. Y-intercept is +2, so I go to where +2 is on the y-axis and put a point. And then the slope tells me down 4 and right 1. So from here, down 4 and right 1. Sort of a very steep line like that. Number 5, also the same idea. Once again, we have a slope-intercept form of an equation. So we have our y-intercept at -2 this time. So right here on the y-axis. And then the slope tells me to go down 2 from there and go over 5. So 2, 4, 5, all the way over here. I'm kind of invading the other graph a little bit. So when we get to a problem like number 6, the thing to understand would be that in this case, with a problem that has 3y equals 5x minus 9, for it to be in slope-intercept form, so you can do what we've been doing for the last few problems, it needs to be a y by itself. So in this case, it doesn't take too much effort to get y by itself. You can just divide the 3 away for both sides, and also make sure that you divide everything on the right by 3. So you're going to be left with y over here, which is good. See, this 5 divided by 3, it doesn't divide evenly, but that's all right. You actually want it to be a fraction because it's a slope. So 5 over 3, x. And then negative 9 divided by 3 is negative 3. So actually, it works out pretty well. So now we're back to a problem very much like the previous 3, where we need to plot our y-intercept at negative 3. Because since y is by itself now, I can actually do that. It's the correct format. I'm going to go up 5 and right 3. I'm trying to draw these lines straight, so if they're a little crooked, I apologize. If we go to number 7, we have a problem that is more or less, to me, the same thing as number 6 was. Because once again, we have a number in front of the y that we want to go away. So, again, this is just a negative 2. Make sure you divide both sides by negative 2. This will cancel, leave it to the y. Good. And negative 3 divided by negative 2, that's 2 negatives, and makes a positive 3 over 2. The x is coming down, and then 4, positive 4 divided by negative 2 leaves negative 2 as our y-intercept. So we can go to the graph now, plot the y-intercept at negative 2. And from there, I'm going to go up 3 and right 2. Plot my other point. Maybe you can see a common theme between all of these problems from numbers 1 through 7, which is more or less that you're given a starting point and you're using Gauss overrun to find the second point. It's really the same pattern through all of those problems. Some starting point, then finding Gauss overrun for the other one. Once you get to number 8, the situation changes a little bit. The problem with number 8 is that you have 3x minus 4y equals negative 12. And the issue here is that you could very well rearrange this so that y is by itself, put it back into slope-intercept form, and then eventually find a y-intercept and use rise over run. But it's kind of not necessarily complicated, but it's more work than you would have to do to figure out how to graph this one. I think any good mathematician would say that you want to find the fastest way to do a problem as long as it is correct. So in this case, you're going to do this by what's called the intercepts method. You're going to find an x-intercept and a y-intercept. So you should know that a y-intercept is a point where it touches the y-axis. Well, see, every line also has an x-intercept, or let's say every diagonal line has an x-intercept too. And that just means that's the point where it crosses the x-axis. You're actually going to find 2 intercepts here. They're pretty easy. When you have an x-intercept, what it means is the y-coordinate is 0. So in a way, you can kind of forget about this whole term right here and solve this as 3x equals negative 12. If you divide by 3, you get x equals negative 4. And the other thing I'm going to do to solve this is find the y-intercept, almost in the same way, except in reverse. I'm going to forget about the x term and solve it as just negative 4y equals negative 12. When I divide, I get y equals 3. So the y-intercept is 3. On the y-axis, put a point where 3 would be. The x-intercept is the same idea, except it goes on the x-axis. So put a point where x would be negative 4, which is over here. And then all you have to do is connect the 2 points and you're done. So you can see this method is a lot easier and really useful if x and y are together like this. If they're together like that, it's typically the best way to do one of these problems. rather than subtracting 3x, dividing everything by -4, figuring out the y-intercept, and then using rise over run. You can do this by the intercepts method, and it's much quicker. A lot of times people can look at these and just figure out what x and y are without even having to write this out. So if you could do that, by all means, go ahead. So number 9 is the same idea. As you can see, again, we have -5x plus 6y equals -30. So because x and y are together, I would solve this using the intercepts method. So the first one I would find, I guess the x-intercept, -5x equals -30. That's going to tell me x is 6. The other one, forget about the x term, 6y equals -30. That's going to tell me y equals -5. So I'll plot the y-intercept on the y-axis for -5 is all the way down here. And I'll plot the x-intercept on the x-axis. +6, 2, 3, 4, 5, 6 is actually going to be way over here, counting all the way over. And you can draw your line and connect that. This one's probably going to be very crooked, but I'll do the best I can to get it correct. So, really, there's two methods for graphing a linear function now. And the one is just a way to make some that are slightly more complicated a little bit faster and easier to do. So if you can remember that you use the intercepts method like this, when x and y are together, it'll probably be a little bit faster for you. And otherwise, you use the y-intercept and rise over run method. For number 10 and 11, they're actually probably the most frequently missed problems, and are probably the easiest ones on the whole graphing set. One of them is x equals -3, and then the other one is y equals 4. So the other thing about this is you sort of have to remember, maybe you can memorize if you want, that when you have an x in an equation without a y, to graph that, it means it's a vertical line. So you need to draw in a vertical line where x is -3. So vertical, hopefully you know, is up and down. So where do I find x is -3? Right here. And that means I need a vertical line there. So I would just draw a vertical line where x is -3, like that. And that's all it takes to graph it. You don't have to worry about slopes or intercepts or anything. It's just a very simple thing. So if a plane x, that is an x without a y, is a vertical, then maybe you could figure out that a y without an x is horizontal. So this says put a horizontal line where y would be 4. Well, where is y 4? Right here. So we need a horizontal line right there. That's all there is to graphing horizontals and verticals. Okay, so now we're on to the other half of the lesson, which is going away from graphing and instead learning how to write linear equations given different types of information. So the key understanding behind this is that you're going to write a linear equation. You might as well always write it in the same slope-intercept format that you've been working with, or y equals mx plus b, as we call it, where m is the slope and b is the y-intercept. So in numbers 12 and 13, it literally asks you to write an equation when you're given everything you really need to write the equation very directly. So in number 12 it says if the slope is -4 and the y-intercept is 5, what's the equation? Well, okay. You know your equation is going to have a y and an x in it. just put the slope where the m would be, in other words, next to x, and put the y-intercept on the end. Positive 5 means plus 5. That's your answer. For number 13, it's the same idea. Put the slope next to x. Put the y-intercept, in this case negative 2, so minus 2, on the end. That's it. We go slightly harder this time. This time you're given a slope, which is good, because you need that, but you don't know the y-intercept. You're just given some random point that the line passes through. But you can still use that information. Knowing that the slope is this, that's a good thing. You'll be able to write your final answer. But ultimately, you still have to figure out what the y-intercept is. So you're missing a piece of information. So my suggestion is to start this by knowing that the generic equation for any line is y equals mx plus b. But what we're going to do is utilize the fact that we know this point is on the line. So this is actually an x, and this is a y for this equation. So what we can do is take our slope and the x and y coordinate that we know to be true and put them in the equation. And it'll leave us with nothing but a b left over. We'll solve, put negative 3 here. The slope is 3 over 5. X is 1. And we're missing just the b that we were looking for to begin with. So this is 3 over 5 times 1 is still 3 over 5. So I have negative 3 equals 3 over 5 plus b. So this is just one more step. I'm going to subtract the 3 over 5 from the negative 3. Subtracting on both sides, this will cancel and give me b equals, well, negative 3 minus another 3 over 5 is going to be negative 3 and 3/5. So our final answer to this, now that we know the y-intercept, is to put the slope we have, 3 over 5, x, and now our newly found y-intercept goes right here. And your problem is done. So I think what you're going to find is that from numbers 14 all the way through the rest of this, from number 14 through 20, you're going to have the same, more or less the same idea. You're always looking for a slope and a y-intercept. Most of the time you're given the slope and you have to sort of find the y-intercept in the same way that we just did right here. So number 15 is more or less identical to number 14 in this process. You're given the slope and you have a point to work with. So if we do our generic equation again, and we put 5 for y, m is 3, and x is 2, b is the only thing left over. This is going to be 5 equals 6 plus b. I would subtract 6 from both sides, and I'll get b equals negative 1. So I can write my final answer over here with our slope that we had from the beginning and our newly found y-intercept. We have our answer. Perhaps that one's a little easier because it doesn't involve any fraction work, but realistically, the two problems are the same process. So here we have some that are very common on standardized tests. So I wanted to make sure that you saw these because it incorporates a few different types of understandings in the same problem. But since your goal is to write a linear equation, it's going to be y equals mx plus b. You still need a slope, you still need a y-intercept. If you read through this, it doesn't specifically say the slope is this or the y-intercept is that. So you really don't know either one necessarily. But I would argue that you can figure out what the slope is using a little bit of logical reasoning and go through the same process that we have been doing to find the y-intercept. So this part right here gives away what the slope is. Parallel, the line you want to write, the equation that you're writing, will be a line that is parallel to this one. Parallel lines have equal slopes, which means that the slope you need is the same as the slope that this line has. So this 3/2 is the same slope I'm going to use for mine, because it told me that it was parallel. Once I have that information, the rest of this is meaningless. All I need is that slope and this point. And if we go back one slide, you can see that's where I was at in number 14 and 15, with a slope and a point. So I'm just going to repeat this same process that I did for 14 and 15, only here I just had to kind of decipher what it meant by parallel to that line. All it's telling me is something about the slope. So I'll start out with the y equals mx plus b generic equation, and I'll put a 5 where y would go. I'll put my new slope in here, and I'll put 4 where x should be, and I'm missing my b value again. This means 3 times 4, which is 12, divided by 2, which is 6. So I get 5 equals 6 plus b, and again I would subtract 6 from both sides. I get b equals -1. So having my slope and having my intercept, I can write my final answer, put the slope in there, 3/2 x, and the new y-intercept -1. So I know I crossed over this equation, but what you can look at here is if your lines are parallel, their slopes should match up, which they do, but they should have different y-intercepts. So let's take a look at 17, see if we can figure out what this is talking about. So the issue here is similar to 16, it gives you some information, but it doesn't tell you exactly what the slope is, and it doesn't tell you exactly what the y-intercept is. So you'll need to, again, decipher what it's saying. When something is perpendicular, what it means is that those two lines will have reciprocal and opposite sign slopes. So the slope that I'm going to use for my line, because it says perpendicular, is going to be the opposite sign of this, so mine will be positive, and the reciprocal means flip it over. My slope will be 4/3. Once again, once we figure out what the slope is, the rest of this information here is meaningless. We need our slope and we need our point. Just like number 16, 15, and 14, it's -4 for y. The slope goes in here, 6 for x, and our missing b value. This is 4 times 6, 24, divided by 3 is 8. So I have -4 equals 8 plus b. I'd subtract 8 from both sides, I get a b equals -12. So my final answer, y equals, the slope I figured out, 4/3, x, and my new y-intercept, -12. As the final answer. So maybe when you're working on number 18, if you're doing this sort of in order, then it's the exact same process as number 17. So perpendicular to this line means that my slope will be the opposite sign. So this one is positive, mine will be negative. And upside down, or flip it over, would be 6/5. Now I don't need this anymore. I'm going to use the point that I was given. I'm going to put -2 for y, -6/5 for the slope, 0 for x. That's going to make this really easy. Plus missing b. So this is actually equal to 0. So what I get is b equals -2. So my final answer over here, -6/5 for the slope, put x in, and my new y-intercept is negative 2. Finally. We're almost there, but hopefully you're starting to realize that these problems all have a very sort of repetitive nature to them, right? It's all about sort of deciphering what is given to you and turning it back into the same kind of problem that you have been working with the whole time. So number 19 and 20, what are meant to be sort of the hardest problems that we have, I'd say again, really are not that bad. In this case, you really aren't given anything. You're not given anything about a slope. You don't have any parallel, perpendicular, nothing like that. All you're given is a couple of coordinate points. And it says, find a line between the two of them. Well, you could do this a couple of ways. You could actually graph the 2 points. Make sure that you draw your line nice and straight using a ruler on a piece of graph paper. Find out where the y-intercept is. And then count up to another point so that you can find the slope. That's certainly one way to do it, and if you can do that, that's fine. The way to do this without going through all of that is to use your slope formula. When you have 2 points, slope formula is y2 minus y1 over x2 minus x1. But we call subtract the y's over subtract the x's. So in this case, it would be 8 minus 4 over negative 2 minus 3. I'm going to get 4. Negative 2 minus 3 more is negative 5. So I have a slope of negative 4 over 5. I still need my y-intercept, so I'm going to pick one of these points to see here again. Here we are with the slope now, and I have a point that I can use. Actually, I have 2, but I only need 1. So back to this method one more time. Now I know my slope. I'm going to pick a point to do this whole process with. So I'm just going to pick the one that doesn't have any negatives in it. Why not? I'll pick this one. So I put 4 where y would go. I got negative 4 over 5 here. X is 3. And finally, I'm missing b value again. So I'm going to get 4 equals, negative 4 times 3 is negative 12 divided by 5. So that doesn't really work out, but what it does give you is negative 2 and 2/5. If you did it on a calculator, you get negative 2.4, which is also okay. So I'm just going to add this to both sides over here. Sometimes when you get fractions like this, you just kind of have to go with it. There's not much you can do to avoid it. This would be b equals 6 and 2/5. So my final answer for y, or my equation that is my slope that I had to calculate, and the new intercept I just got. So you can see that this one is probably more work than the other one. And I guess if you think about it, it should probably be a little bit more work because you're not given anything. You have to calculate everything from the beginning. So it'll take a little bit of time, but ultimately it's the same basic idea. Figure out a slope, figure out a y-intercept, and write your final equation. This one might be a little faster. Let's do the slope again. It's going to be 9 minus 2 over 4 minus from the formula. And then I have a negative 1. So I actually have a minus negative 1 here. Again, if you look at this formula, it has a minus sign in it. So if I write x, 4, minus, then this x is negative 1. I have 2 minuses here. So I'm going to get 7 on the top, and this would really become 4 plus 1, which is 5. So again, I think we're going to run into an issue of dealing with kind of a mess with that fraction, but not much you can do about it. Let's take the smaller numbers this time, I guess. I'll do 2 equals 7 over 5 times negative 1 plus my missing b value. 2 equals negative 7 over 5 plus b. So I'm going to add 7 over 5 here and here. So that I'll get e by itself. I have to do a little math here. 7 over 5 is like 1 and 2/5. So really, I'm saying 2 plus 1 and 2/5, that's 3 and 2/5. Again, if you wrote 3.4 from using your calculator, it would be perfectly open. So our final answer for this one, put in our slope, 7 over 5. And put in our new y-intercept, 3 and 2/5. So surely you're going to get one of each of these kind of problems. So you can basically think of your test as being half as long as this review is. All right, we're on to the last two problems. I had to add these in because I almost forgot, and the truth is that they are probably as important and as likely as anything to be on any kind of test that you'll have. You're supposed to look at a graph and figure out what the equation would be from the graph. What's nice is you should know that anytime you're writing an equation, since it'll have to fit y equals mx plus b, we need a slope and we need a y-intercept. Well, the beauty of this is that the y-intercept is very easy to see on the graph, where it touches the y-axis. So our b is 2 for this one. The question is how do I get the slope? Well, here's another point right here. Well, all I would do is start at the y-intercept. I go down 1 and right 1. Down 1, right 1. Which means that my slope is negative 1 over 1 or just negative 1. So when I go to write my answer for this one, I'll put a negative 1 or just a negative x plus 2. Over here, same idea. Let's get a y-intercept right here where y is negative 1. So I'm going to do y equals x, and I know the end is going to be a negative 1. What do I take to get from here to here? I'm going to go up 1, 2, 3, 4, and right 1. That means my slope is 4 over 1, or just 4. So this one is a 4 here. And that's it. So one of the major skills for this is to be able to take an equation and graph it, or take a graph and figure out the equation. Very, very common problem.